Alright, so I made a pretty amateur mistake there. I was in the middle of my video and my phone filled up, so it stopped recording. So I'm going to have to repeat some things. One thing that I did that I'm pretty disappointed about, because I was making this light for somebody and I wanted to video it for them, is I actually removed the dome from this LED. And you can see I cleaned up those thermal pads as well after I removed them, which you didn't see as well. I don't think I showed you this nice little nifty pair of needle nose pliers either. These are pretty handy for taking apart the tail switches on a lot of the cheaper lights. For example, on this guy, you're going to have a pair of either tweezers with small points or this cool little pair of needle nose pliers there. I was just about to take apart this head. I don't really want to do that though. I was just going to do it because I have to wait till my soldering iron to heat up. But I'm not going to do that because I don't want any more dust to get in there. It's already got some dust. I may actually need to take it apart pretty soon to clean the glass off too. But that's beside the point. The point now is I'm going to have to basically just apply heat to the bottom of this heat sink. We want the whole heat sink to be about 200 to 220, maybe 250. And we want it to sit there for a minute like that and heat up the whole die where the dome meets the die surface, and you want to heat up the dome itself to about 200 degrees. You want it to be nice and hot. You want to touch it and feel that it's warm, so not 200, but it needs to be very warm. And it's got to sit there after you get the whole die up to temperature. You're going to have to sit it there for a little longer. This is also how I remove LEDs that I don't like. Let's see if it's ready. I'll put some solder on there and see if this... Yeah, it is ready. So if the solder melts, I think it's ready. You have temperature controlled and temperature indications on some of your nicer soldering irons. I would actually recommend going ahead and buying one of those when you get started, because once you have a soldering iron, you're not going to want to buy another one, because this one works just fine. I use it. I think these cost like $3 or something. You can get them on the internet. But yeah, see, I'm heating up this the star, moving around my soldering iron. That actually speeds up this process significantly. The actually heating up portion. So you can see I'm touching it, see if it's hot. It's freaking hot now. So I'm gonna just let it sit there for a second. I'll show you my solder. I showed it to you before in the video, but again, it got deleted. This is 6040 lead solder. I like lead in my solder. It's not as good for you with the fumes, but it flows a lot better than your lead-free solder. I've got some lead-free solder. I don't use it though. This is solder flux, and this stuff puts off some serious fumes. It's like burning super glue if you get this crap in your eyes. So don't do that. Try to stand back when you're using your flux. When I use it, I actually used it in that other video, but basically what you do is once you turn your solder gun off and it's cooling down, you take it and submerge it in here, and it gets you a nice little thick metal layer. You flick the extra off, and wherever it lands, you can just scrape it off. It hardens immediately and it scrapes right off, so it's not very hard to clean up. It's going to make like a nice little hard layer on here, and once you get it on there, you want to basically quench it, and just by rubbing off the extra portions. When you do that, you're going to get little balls of solder that gets on your skin. They cool pretty quickly. They might burn for a second, but after a while you just get used to it. Alright, so I'm going to reheat this again. The reason I do this is to keep, you want to make sure that whole dome is nice and soft. Not soft to the point, if you heat it up too much, it'll be soft to the point where the actual dome will come off in several pieces. And you do not want that. The only reason I'm de-doming this one is because I missed in the other video I showed you de-doming, and I heated up too much. The dome came off. This is actually how I mount an LED if I'm going to remount one. I actually take it and I heat up the whole thing. That's what I'm going to do right now. I heat up the whole thing like I just did, and then after it gets hot enough, it'll start to melt with the solder, and then I take it and I put my LED right on that spot, and you can see it kind of like tries to go to the right location. More so with level. Mine's not right now. And then actually hold mine down. Push it down a little bit with your fingernail, even though it's hot, your fingernail doesn't conduct the heat very well, so you won't get burned. Just hold it down, and then it'll solidify pretty quickly. This is a nice, cheap, crappy one. Little cheap aluminum heatsink. One of the problems with most Chinese ones, like this one that I'm using right now, the reason why I took this one out is because this is a difference between XML and XML2. You got these little leads on your LED on the XML, original XML. They're on the negative side, and on the XML2, they're on the positive side. And that's typically how I decide which is the positive and which one's the negative in relation to where I'm soldering it. So you can see it right here. I'm taking this bare razor, and I am slipping it right underneath the dome where it meets the surface of the die. And I'm just going to lift very slowly. The reason why you apply heat is because it takes the layer of the dome that is attached to the LED. Actually, I fractured it, so there's several pieces now. The other one I got first try, so it stinks that I didn't get that one on the video. Don't touch right above the LED. If you're going to screw up and try again on the sides. I've actually found too that it's easier to de-dome your newer LEDs, the XML2 series, than it is these XML LEDs. I was very happy with the new line. They're more efficient, and they're actually cheaper to buy brand new than these XML2s were, so I'd highly recommend them. Well, they're cheaper for the manufacturers, but they're not necessarily cheaper for you, because every one that I bought has been much more expensive now. But anyway, it doesn't matter. So if that's what happens when the LED is too hot, the dome is too hot, you'll basically get like a small layer of dome material on the actual LED surface. The reason why that happened is because it is aluminum and not copper. I'm used to doing copper. But here's my other one, and you can see it's perfect. First try, you just kind of let it sit for about a minute or so in that heat, and then you just remove that dome right off, and it comes off clean. So now I also took that white stuff I was telling you about right off of there. So I just do that with a t-shirt. It comes right off. It's nice and liquid still. No problem. So we will take our new heatsink compound and we will apply it to both surfaces. Like I said, I'm going to use Arctic Silver 5 today. I like that Icy Diamond. The Arctic Silver 5 flows better than the Icy Diamond does. The Icy Diamond's almost it's almost solid, really. It's kind of like putting putty on there, while this is it's a little thicker than that. This stuff is a little thicker than your average thermal paste, like the white stuff that you see. That stuff's pretty liquid. This is a little thicker. It's got you know, you can read up on Arctic Silver 5 before you buy some yourself. It's pretty expensive. This is the biggest one that I could get. I think it's like $15. Put it to both surfaces. Actually went a little overboard there. You don't really need that much. Reason why you put it to both surfaces, you just don't want to have any portions under there that don't have a covering of Arctic Silver. Because now what you want to do is push it in and kind of wiggle it. The reason why you don't want any surfaces that don't have it is because all of the heat is going to go through the least resistance path. Just like water when it flows, just like electricity when it flows, heat flows in a very similar fashion. So you want it to flow evenly. That way all 31 millimeters, you get the highest heat transfer surface area. As you know from probably high school, surface area is one of the biggest thermal conductivity parts of the thermal conductivity equation. The more surface area, the better. That's why you got a 31 millimeter on here, whereas, you know, like my little 18650, you know, P60 module only uses a 16 millimeter heat sink. It's because we're going to be generating a lot of heat. This is only, you know, they claim this is a 10 watt LED. I'm going to be pushing it probably more than 20 watts. So you can calculate it out. 6 amps, my forward voltage is going to be somewhere in the 4 volt range. So, alright,